Good afternoon, friends. In last lecture, we discussed about effectiveness and NTU method. After that, what is meant by effectiveness, what is meant by NTU, what is meant by heat capacity ratio, and after that, we derive the equation for the effectiveness of the parallel flow heat exchanger. Parallel flow heat exchanger. Now we discuss that is next point, that is effectiveness of counterflow heat exchanger, the derivation of effectiveness of counterflow heat exchanger. So first of all, what is meant by counterflow heat exchanger? So counterflow heat exchanger is nothing but the direction of hot fluid and cold fluid is opposite. The direction of hot fluid and cold fluid is opposite. That is nothing but counterflow heat exchanger. That is nothing but counterflow heat exchanger. So this is the graphical representation. So this is the graphical representation of the counterflow heat exchanger. So what is the graphical representation? So this is the line of the hot fluid and this is the line of the cold fluid, that is temperature variation for the hot fluid, and this is the line for the temperature variation for the cold fluid. So hot fluid is flowing from this direction to this direction. Hot fluid is flowing from this direction to this direction, and cold fluid is flowing from this direction to this direction. So inlet temperature of hot fluid is TH1 and outlet temperature of the hot fluid is nothing but TH2. Similarly, inlet temperature of the cold fluid, that is TC1, and outlet temperature of the cold fluid, that is TC2. So in this we have to considering the small area. So this area is nothing but small area. And what is the temperature difference? So for this small area, temperature of hot fluid is TH and temperature of cold fluid is TC. Temperature of cold fluid is TC. So along the x direction, what will happen? The temperature of hot fluid is reduces. The temperature of hot fluid is reduces by the dTH. What is the temperature difference for the hot fluid for that particular small area? That is dTH. And similarly, in the opposite direction of x, the temperature of the cold fluid is increases. Temperature of the cold fluid is increases. So in what quantity that temperature is increases? That is nothing but dTc. So from this point to this point, that particular small area, from this point to this point, what will happen? The temperature is increases by dTc. Temperature is increases by dTc. So this direction is opposite to the x direction. This direction is the opposite to x direction. So this temperature difference, that is TH and TC, this temperature difference is nothing but theta. This temperature difference is nothing but theta. And this temperature difference, that is TH1 and TC2, this temperature difference is nothing but theta 1. In the parallel flow heat exchanger, here is a TC1. TH1 minus TC1 is nothing but theta 1. But for the counter flow heat exchanger, so this difference, that is TH1 minus TC2, is nothing but theta 1. And what about the theta 2? This temperature difference, that is TH2 and TC2, this temperature difference is nothing but theta 2. Now we have to start the derivation, that is heat exchange dq through an area dA of the heat exchanger is given by. So for this particular elemental area, so what is the elemental area? That is dA. So for this dA, what is the value of heat exchange? So there is a small element, so heat transfer is also small. So we have to considering the small heat exchange, that is dq. So what is the value of dq? dq is equal to U into dA into bracket TH minus TC. TH minus TC. So similarly, what is the value of dq for the hot fluid? So this temperature difference into mass flow rate of the hot fluid into specific heat of the hot fluid. So how to write that? M dot H into Cph into dTh. So for this particular area, temperature difference is this small amount, that is dTh. So M dot H into Cph into dTh, and negative sign is due to the along the x axis, along the x direction, what will happen? Temperature is reduces. Along the x axis, temperature is reduces. So because of that, negative sign is taken. Similarly, temperature of cold fluid. So this is the direction of the cold fluid. This is the direction of the cold fluid. So in this direction, that is opposite to x direction, temperature is increases, but in the along the x direction, temperature is reduces. So because of that, along the x direction, this temperature is reduces, so we have to taken the negative sign. So the product of mass flow rate and specific heat, that is nothing but heat capacity. So what is the equation? So dq is equal to minus capital Ch into dth is equal to minus cc into dtc. So from this equation, so what is the value of dth? Dth is equal to dq divided by minus ch, and dtc is equal to minus dq divided by cc. So we have to subtract this term to this term from the dtc. So dth minus dtc. So here the equation is wrong. So what is that equation? dtc is equal to this term, that is dtc is equal to minus dq upon cc. So dth minus dtc is equal to what? Minus dq into bracket 1 upon ch minus 1 upon cc, 1 upon ch minus 1 upon cc. So what is the final equation? So dq is equal to 1 upon cc minus 1 upon ch, 1 upon cc minus 1 upon ch, because this minus this, so this term becomes positive. So 1 upon cc becomes positive, and this term as usual negative. So dq into bracket 1 upon cc minus 1 upon ch. So from this equation 1, put the value of dq as a u into dA into th minus tc. So put the value of that, that is u into dA into th minus tc. So in this equation, so d into bracket th minus tc as the same. So what is the value of dq? Dq is nothing but u into dA into bracket th minus tc. So we have to write only u into dA, and we have to take this th minus tc into left hand side. So it is in the product. So in the left hand side, it is at the denominator. So th minus tc. So what is the remaining term at the right hand side? That is u into dA into bracket 1 upon cc minus 1 upon ch, 1 upon cc minus 1 upon ch. So temperature is changing from inlet to outlet. So at inlet we have to giving the suffix 1, and at outlet we have giving the suffix 2. So we have to take the integration of this, integrating the from 1 to 2. So th minus tc is nothing but theta. So d theta divided by theta, and integration is changes from 1 to 2. So d theta by theta, what is the integration of that? That is ln theta, and integration is changes from 1 to 2. So what is that value? Ln of theta 2 by theta 1. So what is the value of theta 2? Theta 2 is nothing but th2 minus tc1, th2 minus tc1, and what is the value of theta 1? That is th1 minus tc2, th1 minus tc2. Similarly, take the integration of the right hand side, but area is changes from 0 to capital A. Area is changes from 0 to capital A. So what is the integration of dA? Integration of dA is capital A, and that area changes from 0 to capital A, means what? A minus 0. So directly there is answer of that term, that is A. So u into A into bracket 1 upon cc minus 1 upon ch. So how to write that equation? Ln of th2 minus tc1 divided by th1 minus tc2 is equal to, we have to take the common from this term, that is cc. So uv upon cc, what is the remaining term in the bracket? 1 minus cc upon ch, 1 minus cc upon ch. So at the left hand side there is a ln, so we have to cancel that ln. So how to cancel that ln? By taking the exponential. So exponential and logarithmic are opposite terms, so ln is cancelled to the exponential. So ln and exponential are cancelled. So what is the remaining term in the left hand side? That is th2 minus tc1 divided by th1 minus tc2. And so what is the right hand side? Taking the exponential. So exponential of right hand side, that is uv upon cc into bracket 1 minus cc upon ch, 1 minus cc upon ch, 1 minus cc upon ch. So Next, but what is the value of effectiveness? What is the value of effectiveness? So effectiveness is nothing but Q actual upon Q maximum. So what is the Q actual for hot fluid? That is CH into bracket TH1 minus TH2 divided by C minimum into TH1 minus TC1. So this value is nothing but Q max. Q max, what is the formula for Q max? That is C minimum into bracket TH1 minus TC1. Similarly, what is the formula for cold fluid? That is Cc into bracket Tc2 minus Tc1 divided by C minimum into bracket TH1 minus TC1. So from this equation we have to write the equation for TH2 and we have to write the equation for TC2. So what is the value of TH2? So by the rearranging the term, so what is the value of TH2? So TH2 is equal to TH1 minus epsilon into C minimum into bracket TH1 minus TC1 divided by capital CH, and that equation is nothing but equation number 4. Similarly, from this, that is epsilon is equal to this term, so from that we have to write the value of TC2. So TC2 is equal to what? TC1 plus epsilon into C minimum into bracket TH1 minus TC1 divided by Cc, and that equation is equation number 5. So substitute these values in equation number 3. So we have to put this value of equation 4 and equation 5 into equation number 3. So TH1 minus, we have to put that value of TC2. So what is the value of TC2? That is this value, and put that value into this equation. So what is that equation? So TH1 minus epsilon C minimum into bracket TH1 minus TC1 divided by CH. So this is the value of, sorry, TH2. So this is the value of TH2 minus TC1. So this is the value of TH2. Similarly, TH1 minus TC2. So what is the value of TC2? So put that value into this equation. And what about the right hand term? That is same. That is exponential of UA upon CC into bracket 1 minus CC upon CH. 1 minus CC upon CH. So take the modification in this equation. So what is that equation? So TH1 minus TC1. TH1 minus TC1. So we have to TH1 minus TC1, we have to take the common from this term and this term. So what is remaining? 1 minus epsilon C minimum upon CH. And similarly for the bottom denominator, we have to take TH1 minus TC1 common from these two terms. So what is the remaining? TH1 minus TC1 into bracket 1 minus epsilon C minimum upon CC. Right hand term is same, that is exponential of UA upon CC into bracket 1 minus CC upon CH. So this TH1 minus TC1 and this TH1 minus TC1 will cancel. So what is the remaining term? 1 minus epsilon C minimum upon CH and 1 minus epsilon C minimum upon CH, and right hand term is same. Suppose assume, now we have to assume that CC is less than CH. CC is less than CH. Then CC is C minimum and CH is C maximum. CC is C minimum, CH is C maximum. So instead of CC we have to put the C minimum, and instead of CH we have to put the C maximum. So put that value into equation number 6. So what is the equation number 6? That is 1 minus epsilon C minimum upon, this is CH. So CH is nothing but C max. So C max. So similarly 1 minus epsilon into C minimum divided by C minimum is equal to exponential of the UA upon C minimum into bracket 1 minus C minimum upon C max. So next, that is 1 minus epsilon into C minimum upon C max. C minimum upon C minimum, that is 1. So 1 minus epsilon, and the right hand term is same. So now I have to take this 1 minus epsilon into the right hand side. So what about the left hand side? That is 1 minus epsilon into C minimum upon C max is equal to, so multiply this right hand term with 1 minus epsilon. So first term will be same, that is exponential of UA upon C minimum into bracket 1 minus C minimum upon C max, minus epsilon into this term. So epsilon into exponential of this term, that is UA upon C minimum into bracket 1 minus C minimum upon C max. C minimum upon C max. C minimum upon C max. So next, so what is the left hand side term? 1 minus exponential of UA upon C minimum into bracket 1 minus C minimum upon C max, bracket complete, is equal to, so take, so epsilon is equal to what? C minimum upon C max minus exponential of UA upon C minimum into bracket 1 minus C minimum upon C max. So take the arrangement in the equation. So what is that equation? So our aim is to calculate the effectiveness. So effectiveness is equal to what? Effectiveness is equal to, so in the how this equation is come, because in left hand side there is a C minimum upon C max, and we have to take the common from these two term, that is epsilon. So we have to taken the common as a epsilon. So what is the remaining term? That is C minimum upon C max minus exponential of US C minimum into bracket 1 minus C minimum upon C max. So now subject is epsilon. So how to write that epsilon? So epsilon is equal to what? Epsilon is equal to this term divided by this term. So 1 minus exponential of UV upon C minimum into bracket 1 minus C minimum upon C max. And what about the denominator? So this term is comes at the denominator, that is C minimum upon C max minus exponential of UV upon C minimum into bracket 1 minus C minimum upon C max. Now we have to interchange the parameters. So epsilon is equal to, we have to take this term at minus 1, so, and we have to take the denominator also same, that is we have to take this term at the left hand side and this term as the right hand side. So epsilon is equal to exponential of UV upon C minimum into bracket 1 minus C minimum upon C max minus 1, and similarly we have to interchanging the sign, that is exponential of UV upon C minimum 1 minus C minimum upon C max minus C minimum upon C max. So by rearranging terms we got the final equation of effectiveness, that is 1 minus exponential of minus UV upon C minimum into bracket 1 minus C minimum upon C max, and at the denominator that is 1 minus C minimum upon C max exponential of minus UV upon C minimum into bracket 1 minus C minimum upon C maximum. So rearranging this equation we got the final equation. So in this equation, so what is the value of R? R is nothing but C minimum upon C maximum, and what is meant by NTU? NTU is nothing but UV upon C minimum. So instead of UV upon C minimum we have to put the NTU, UV upon C minimum we have to put the NTU, and instead of C minimum upon C maximum we have to put the R, that is heat capacity ratio. So what is the value of effectiveness? So effectiveness is equal to what? 1 minus exponential of, so minus UV upon C minimum is that is nothing but NTU, and C minimum upon C max, that is R. So 1 minus exponential of minus NTU into bracket 1 minus R, and what about the denominator? 1 minus R into exponential of minus NTU into bracket 1 minus R. So this is the equation of effectiveness of the counter flow heat exchanger, effectiveness of the counter flow heat exchanger. So what is the equation of effectiveness of parallel flow heat exchanger? That is effectiveness of parallel flow heat exchanger, that is 1 minus exponential of minus NTU 1 minus R divided by 1 plus R. And what is the equation for the effectiveness of the counter flow? That is 1 minus exponential of minus NTU 1 minus R divided by 1 minus R exponential of minus NTU into bracket 1 minus R. So these are the equations of the equations of the effectiveness of the parallel flow heat exchanger and effectiveness of the counter flow heat exchanger, effectiveness of the counter flow heat exchanger. So let us discuss two limiting cases of equation 1 and 2. So equation 1 is nothing but effectiveness of the parallel flow heat exchanger, and equation 2 is nothing but effectiveness of the counter flow heat exchanger. So there are two limiting cases. So first case is when R is equal to 0. So R is equal to 0. So what type of heat exchangers that R is 0? So R is 0 means what? C minimum divided by C maximum is equal to 0. So for the condenser and evaporator, the value of C maximum is infinity. For the condenser and evaporator, the value of C maximum is infinity. So what is the meaning of that? C max is infinity means R is equal to 0. C max is equal to infinity means R is equal to 0. So from this, what is the effectiveness of the parallel flow heat exchanger? So in that equation number 1 we have to put the R is equal to 0. So what is the value of effectiveness of parallel flow heat exchanger? That is 1 minus exponential of in bracket minus NTU. And what is the value of effectiveness of counter flow heat exchanger? So we have to put the R is equal to 0 in equation 2. We got the value of effectiveness of counter flow heat exchanger when R is equal to 0. That value is nothing but 1 minus exponential into bracket minus NTU. Means what? Effectiveness for the parallel flow and counter flow is same when R is equal to 0. R is nothing but heat capacity ratio, and heat capacity ratio is 0 for the condenser and evaporator. And so means what? For the condensers and evaporators, C maximum is equal to infinity, and because of that R is equal to 0. And if R is equal to 0, then effectiveness is equal to what? 1 minus exponential of minus NTU. By using that formula, we have to find out the effectiveness for the parallel flow and counter flow heat exchanger. Case number 2, when R is equal to 1, and this condition is satisfied for the regenerators. This condition is satisfied for the regenerator. So put the R is equal to 1 in equation number 1, that is effectiveness of parallel flow heat exchanger. So by putting R is equal to 1, we got the effectiveness of the parallel flow heat exchanger. And what is the value of effectiveness for the parallel flow heat exchanger? That is 1 minus exponential of minus 2 NTU divided by 2. So by using this equation, we have to find out the effectiveness of the parallel flow heat exchanger when R is equal to 1. But for the counter flow heat exchanger, when we have to putting the R is equal to 1, so that expression of effectiveness which is in indeterminate form. So how to find out the indeterminate form? By using the L'Hospital rule. So we have to take the derivative of numerator and denominator and find out the value of that effectiveness. So what is our equation? That is 1 minus exponential of in bracket minus NTU in bracket 1 minus R divided by 1 minus R into exponential of minus NTU 1 minus R, and limit R changes to 1. So exponential of so what is the derivative of numerator? So derivative of exponential, that is e raised to that term, that is NTU into 1 minus R. So we have to take the write this term as arrange the term in the form of this, that is exponential of NTU 1 minus R minus 1 exponential of NTU 1 minus R minus R. Now differentiate the numerator and denominator of this term with respect to R and taking the limit R tends to 1. So derivative of this term, that is e raised to x. What is the derivative of e raised to x? That is e raised to x into derivative of x, that is derivative of this term, that is minus NTU. Similarly, we have to take the derivative of this term, that is e raised to this term means e raised to this term into minus NTU, and derivative of R is 1. So put the value of R is equal to 1. So by putting R is equal to 1, this term becomes 0, that is e raised to 0 is nothing but 1. So what is remaining? That is minus NTU. Similarly at the denominator, e raised to 0, that is 1 minus NTU. So minus NTU is present, e raised to 0 is 1 minus 1. So minus, we have to take negative sign common. So negative will cancel. So what is remaining? NTU upon 1 plus NTU upon 1 plus NTU upon 1 plus NTU. So by using this formula, we have to calculate the effectiveness of the counter flow heat exchanger. Effectiveness of the counter flow heat exchanger, that is NTU divided by 1 plus NTU divided by 1 plus NTU. So by using this formula, we have to find out the effectiveness of the counter flow heat exchanger when R is equal to 1. So case number 1, when R is equal to 0, then effectiveness of parallel flow and counter flow heat exchanger is same. And what is the value of that? That is 1 minus exponential of minus NTU. And if R is equal to 1, then effectiveness of parallel flow heat exchanger is 1 minus exponential of minus 2 NTU divided by 2. And for the counter flow heat exchanger, effectiveness of the counter flow heat exchanger is equal to what? Is equal to NTU divided by 1 plus NTU. So by using these formulas, we have to find out the effectiveness of heat exchanger for the different cases. So there are two cases. Case 1 is R is equal to 0, and case 2 is when R is equal to 1. So by using these equations we have to find out the effectiveness for these particular cases. R is equal to 0 for condensers and evaporators, and R is equal to 1 for the regenerators. So thank you very much.